let's look at part C of this number 14. So number 14, we made our buffer out of acetic acid and acetate ion, okay? And so we had concentrations of each thing after we mixed the volumes, and we know the pKa of our buffer system, and that was the original pH, okay? And then part B, we practiced calculating pH when we add acid. And so now part C is how does the pH change when we add base? So we are still going to think Ba, okay? Moles before, but now we're adding base. We're increasing the amount of hydroxide ion. And so we want to calculate how many moles of OH minus did we add. After adding a base, so this is the difference now, okay? This is the main difference. After adding a base, you are changing your equilibrium, right? You are shifting the base, the buffer equilibrium. But base is going to shift which way? Opposite of what the acid did. The acid shifted it in reverse. Adding a base is going to shift it forwards.
So less AJ, more AJ.
Yes. Good. You're getting it.
Am I?
Yes. Now you should have less of the acid in the buffer, and you should have more of the conjugate base in your buffer. Okay. So I think I didn't change any of the amounts on part C, like the before amounts. Okay. I still said on part C, let's add 0.200 liters, right? So this calculation is identical to what you did in the previous part. If it's a multi-part and you just want to refer back to those calculations you already did, yeah, duh, do that. But if you're starting over brand new with this problem, you would need to do this mole calculation, right? So this is how many moles of HA and moles of A minus before adding anything, right? That's our B. And our diluted HA molarity is 0.100. So we're going to end up with the same 0.0200 moles of HA.
You just did just say we can use the same.
Yes, if you have a multi-part question and you've already calculated this number of moles, just use what you calculated before, right? But if you're starting over from scratch with a question, you'd have to calculate the moles before, right? And this is how you would do it. Point 3, yes. Okay. What about the addition? Okay, OH. I'm adding sodium hydroxide, which is a strong base. So like we saw before, when sodium hydroxide goes into water and it splits, it's a 1-to-1 ratio of this molarity to the molarity of the OH minus. So if this is 0.050, then this is 0.050. Because of what? Because the sodium is inert, and because this is a strong base, so it fully dissociates. So how many moles of hydroxide ion did we add? volume times the molarity. Volume was 5.00 milliliters. So if I think of that in liters, so I can multiply by my molarity. It is 0.0. 2.5 times 10 to the negative fifth. Is that right? Somebody check my math. Is it negative 4?
Yeah.
Catherine's like, I don't know this folks. I was trying to do my fancy math in my head.
I know, but
Not you.
not that kind of math.
Yeah.
I can do everyday math.
Yeah. Okay. Now what?
I mean,
After. Bah.
I just think it'd be amazing.
Bah. Banana. Ooh, banana. Ooh, banana.
So now you're gonna add
Hmm?
with the A minus.
So now, if I want the moles of HA in my buffer system, I do the before moles and I subtract the moles I added. And if I want the moles of A minus, I add.
Okay, so that could be for every time.
It is every time, Caitlin.
So if it's for HA, it's minus, it's for A minus plus.
When you add what specifically? OH minus.
Okay.
If you look at what we did on part B, it was switched. And
Okay.
And it is always that way, Caitlin. Always. It is always that way.
That was the light bulb moment right there.
Good. That is a good light bulb moment to have. It is an excellent connection to have in your brain. So let me see. Let's look at that. That's number 15. I want to do 15. Let's look at that. We'll look when we have a weak base buffer. We'll look at that. So how much?
I got 0.0202.
Hang on. So we're doing HA minus this, right?
Oh, I added.
That's
0.019.
So, and note what decimal place our little answer is going to, right? We're going out to 4 places past the decimal. That's as far as that one goes. This actually goes to 5 places past the decimal. Right? But so I want to stop my answer at the 4 places past the decimal. So I would write my moles of HA after. I would write 0.0198. Okay. That is moles. And like I said earlier, I don't have to calculate the molarity of this because that division of the volume it cancels out in my HH equation. It's a useless, unnecessary math step. And so then this one is Hmm.
No. 0.0.
Did you add here?
0.06. Oh, no, I pushed the front.
Okay. 0.0603 moles of A minus. That's me adding these two numbers and rounding to the 10,000th place, 4 places, rounding to 4 places past the decimal. Okay. So now what should be the pH of this buffer after we add this amount of base? Let's see. No. Okay, I'm glad you asked this. POH is when the buffer system is a weak base. My buffer system is acetic acid and the acetate ion. My buffer system is not a base. My buffer system is an acid. I added a base to it, but that does not mean we use POH here. Okay. So same pKa in this 4-step, 3-step problem that we found up at the very beginning. It's the pKa for acetic acid buffer system, which is always the same value depending on how many sig figs you take out. Okay, A minus on top, so 0.0603 divided by 0.0198. What do you expect this number to be?
Smaller.
Compared to what it originally was. It originally had a pH of 5.222.
More volume. I'm smaller.
This is very interesting to me.
Smaller. I bet 20 bucks is smaller.
Deal pickle. 5.229. You said $20. 20 cents. I added a base. The pH goes up.
I put the same thing in my calculator and I got a 4.2.
I don't know.
I got 5.2. Okay, so it goes up from the original.
Yeah, it goes up. When I originally made my buffer, it had a pH of 5.222. Oh, okay. That would make it. When I add some hydroxide to it, the pH does go up, but does it go up very much? No, not at all. And we saw that earlier when I was testing, right? Okay. All right. Well, let's do this one. What part is not always like what?
Because when we add acid, sign switch. For example, when we wanted to calculate A, B, subtract.
This is true when you add base. The other is true every time you add acid. This is true every time when you add base. Only when you add base. Okay. The other is true every time if you're adding acid. Yeah. Yeah. Can you calculate? Can you do calculations if you were adding a weak acid? Sure, but you'd have to do an equilibrium calculation first to figure out the concentration of H3O plus, and then do that. Hey, buddy. We decided that we needed extra lecture today more than a lab. But I do need to give you something, which is a worksheet for over the weekend. So hang on, let me print that real quick. You guys start looking at 15. It's not scary. Robert, it's a little scary. It's not scary. It's a little scary. It's not scary, you guys. My gosh. Okay. Y'all are looking at this. Also, Robert, we might not have this test on Tuesday. We might have it Wednesday. Everybody seems to like that, so I'm okay with that, I think. I also said I think I might let y'all make 2 note cards for this test. Well, yeah, the average on this test was a 53 the last time. So
It might get 2 note cards.
Without the curve, bro.
maybe I'm thinking about letting y'all have yeah, without the curve. Yeah, it was without the curve. What if that was with the curve? Woo! Woo! Okay, what am I looking for? That was 2 springs. That was 3 springs ago. And that the high grade that spring, the average that spring was like a 60 something, and the high grade was a 95. But I mean, it's obviously doable. Obviously. But that semester the low grade was like a 23, so it's like it's kind of not a nice bell curve, I'll tell you that. Wasn't a nice bell curve. Okay, are you guys looking at this question I have on the board? I mean on the screen. I'm still trying. I know. I'm sorry. I gotta quit talking, otherwise I can't find this file. So just 1 minute. Where did it go? Okay. Y'all see if you can do part A, because it's the same method steps that we did for number 14. It's just now we have a base buffer system. Okay, so if I didn't give you volumes, then what can you just use? So what it says is the solution is made so that it is 0.5 molar. So that's what it already is now in the buffer. So those are your concentrations. This is not a dilution. This one, you don't have to dilute. When's the only time you got to dilute? You got to worry about that. If it says mix this volume and this volume, like if it actually describes mixing volumes, then dilution time. Okay. All right, and I'll be right back.
For English, a buffer solution is prepared that is with.
So what precision is prepared that with?
Going to be on. No, I'm being with 0.50.
Prepared with?
Yeah. That makes more sense. I put it down here. It was done. Right. Oh, this is the PM. Oh, wait. Yeah, and then the pH after. Right. Yeah, I have equations. So let's see if we have. She doesn't have very much.
There's oh, yes, and then it's 14 minus 3, yeah.
Okay.
Does that help?
So it's basically the same equation that pH and the acid term.
I'm gonna do it like this. So not that.
And I always do it. I'm Savannah. I'm worse. My eyes are worse than my mother's. And that's really saying something
Uh-oh. Uh-oh. Why are we confused? Hang on. No, pH 15 is not correct. Okay, hang on. Let's. Yeah. I mean, while you can technically have negative values for pH and pOH, it's not common, and that's certainly not the case here. It means that the concentration is super duper high. Well, let's look. Okay, I just put on the screen what I got, but let me work it on the board with you guys. Let's work it. Plus, I think this is the one
Oh, I know what I did.
where I've got maybe a little tip that can help. Okay, so we're looking at number 15. Again, I told you guys, I promise you guys, there's a test question. I show your work. That's like 14 and 15.
I know what I did.
Okay. So let's be sure we're spending this time, right? So let's be sure we all leave here today knowing how to do these. So,
Joseph, what were you going to say?
I was just saying, like, so there's just one of these on the test?
so there's one that's like do all three sorts, but that doesn't mean there couldn't be just a multiple choice that was a more simple or just one part thing. Yeah. 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 Okay. So guys, we have a buffer because it says it's a buffer in the description, but also we have a weak base and its conjugate acid. That's a buffer. Okay. This buffer is basic. So it doesn't have a Ka value, it has a Kb value. And its Kb value is 1.8 times 10 to the -5. Hot damn.
Yeah, we don't have the KB.
We have the PKB.
On our sheet.
We got PK.
I went ahead and gave you the PKB.
That's what I did wrong because I saw for the PKB.
Oh, why did I do that? That's weird. Okay. Anyway, all right. Okay. That's fine. I don't know why I felt like doing that day, but okay. Here's the PKB. We already have it. Yeah, right. Except then I'm gonna screw somebody up like you who's gonna try to solve the P of the PKB. Okay, 4.75. PKB, 4.75. So because this buffer is a base equilibrium, is that what you did? Okay. When I use the HH equation, I'm not solving for pH, I'm solving for POH. I'm solving for OH. Okay. So, what did it say? Wait a minute, real quick. In the problem, it went ahead and gave, this is what, Caitlin, you were asking a little before. It didn't describe mixing volumes. It just said the buffer is this and this. So that means this is no dilution here. I'm telling you, it's kind of like maybe I already calculated the diluted for you. There it is, right?
You also use that English.
What did I say? A solution is prepared that is,
Isn't it B with?
that is 0.050 molar. That is this. It is this. That's not bad English. That's the correct tense. It is this. It is this. And this is the 0.50 molar.
I'm out of practice.
Well, chemistry language is a little, I mean, tenses get a little funky. I'm not disagreeing on that. So 0.50 molar NH3, and it's 0.20 molar in this compound. So POH equals PKB plus the log of the base and then the conjugate on top.
Once I realized I'm taking the negative log of the PK.
Well, that'll do it.
That's right.
Okay. Conjugate is 0.20. Ammonia is 0.50. So what is our POH of this buffer mixture? 4.35. And so the pH is 9.65. Perfect. E, relatively easy. Yeah. 3 points. 3 points. 3 points. Well, okay. Now what's going to happen if I add some acid to it?
You're going to add some hydronia.
The pH is going to go down, but it should only go down a little bit. I'm going to add some H3O+. I'm going to add some hydronia to it. What am I describing in part B? Now I'm ball. Now it's time to ball. Okay? Now it's time to ball. Oh, I'm adding a base first. I'm sorry. Excuse me. I'm adding a base first. Okay. All right. I went a little out of order here. That's fine. It doesn't matter. It's not like there's an order. I don't have to do one then the other. It's whatever. So, okay. It's still the same thought process. Mm-hmm. Now here I'm gonna. I think. Do I want to do this here? Hang on. Let me look at my numbers real quick. Oh, I don't want to do this here. Never mind. I'm just. Don't worry about what I was thinking. Let's just do what we've been doing. We're good. Okay. So I am taking 1 liter of the original buffer, and I'm adding 0.010 moles. Okay. So let's think before I am wanting the moles of my base, my weak base, and the moles of the conjugate acid of that base. I want the moles of OH minus that I'm going to add. And I was kind of nice here because I just straight told you, here's how many moles. All right. Okay. So now this is where we got to think which one is going to decrease and which one is going to increase. So if I'm adding a base, I'm adding strong base, the conjugate acid is what's going to attack it, right? Some of this is going to go away attacking that. There should be less conjugate acid. I should have more of the weak base created. Okay, so this is part B for number 15. So let's calculate. For the ammonia, for my base, I have 1 liter described in the problem, volume of 1 liter. Oh, that was not. Damn, this is nice. How did I do all this nice stuff in this question for you guys? I have no idea either. Okay, so times the, because in my head when I made this 4 years ago, I knew this particular class was going to be struggling at this point on this day, and I on purpose made this question easy for this reason. Hey, I did. Go, Carrie Poe. Being clairvoyant and all that. Not BH. Oh, well, because I'm thinking. Okay. Chill out. I'm tired. I know you guys are tired too. But y'all are doing, I don't know, I feel a little bit. Y'all feel a little better?
Is our homework like this?
Yeah. Yeah. I'm going to tell you at what point you can get through your homework over the weekend, okay? Since we didn't get to the last section, I'm going to tell you at what point you can get to your homework, okay? So let's finish this. So I just have 0.5 moles of base and 0.20 moles of conjugate acid. And then I'm going to add.
Well, you already gave us the most.
I did. So that was super helpful. 0.01. Yeah. Okay. Nice. Okay. And so now after. Let's see. So my moles of base. I'm going to take the moles of base that I had before and do what? Add the moles of strong base that I added. .51, right? That's pretty easy.
Yeah, but I really hope it's easy.
I don't know. We'll see. Maybe I'll be nice. Moles before minus moles added. .19, right? Okay. Remember, I'm solving for pOH with this particular buffer. Y'all are going to write pH. I already know it.
I just did that.
I know. I already know it. Because you're like, pH, 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 I need pH. Okay, but we're finding pOH because this is a base buffer. Okay, pKb. So 4.75 plus. And just like before, I don't need here to recalculate a new molarity because that's kind of a redundant division of both mole amounts when I'm doing this ratio. I can just take the log of the moles, the ratio of the moles, 0.19 over 0.51. My pOH then is
4.2.
let's see what I got. pOH is 4.32. Yes. And so pH is, did it go up or down from what we started with? Up a little bit, which we should have expected. Y'all want to try C? And then we're done. Yeah?
For the day?
Yeah. Yeah.
Let's do it.
Yeah, that's how I feel.
It's one for you.
Yeah, I'm done. I'm done. So done. So done. I'm ready for Easter too. I'm ready for Easter too.
Ready for Sunday. You can use the same before, right?
Yep. Okay, so on C, once again, I'm using 1 liter of buffer, of the original buffer from part A. So you can calculate your befores, and now we can calculate the added moles of H3O plus. How do we calculate the moles of H3O plus given these two numbers? Look back at what we did on 14. Look at what we did, number 14, parts B, where we added the acid. How did we calculate that? Multiplied volume. We changed this from milliliters to liters, and we multiplied volume times molarity. Yep, that's how we did that. Can you do the same thing here? Should you do the same thing here? That's how we get moles. That is absolutely how we get moles.
So we have the H3O plus instead of the
Yep, we are adding H3O plus instead of OH minus. We are adding acid instead of base. So it's the same moles before because I'm using the same 1 liter of solution. If I was using a different volume, would I have to calculate the new amount of moles? Yes, but this is the same as we saw in part B. 0.5 moles of B, 0.2 moles of conjugate acid. The moles of H3O plus added. 0.0300 liters. That's my 30 milliliters in liters times 1 molar, 1 mole per 1 liter.
And it'll be less B, and more HB.
So, yep. So when we add acid to this base buffer, right? The base, the B, our weak base, is what is going to attack that, right? Yeah. And so we end up with less weak base, but more conjugate acid. Less and more. So my moles of ammonia of weak base in my buffer is the before moles, and then what? Minus or add? Minus less moles of acid. Well, do you mean who came up with buffer numbers, or who came up with how to do these calculations, or why we need to do these calculations? You have to do this. Yeah, right. Like, oh yeah, no, and they wouldn't. They don't have a clue about any of this at any point. Aren't you special now? You're like in a special little secret society. Secret society. Yeah.
Secret Society of Associated Power, SSA.
Okay.
It's something for my book.
Okay. Okay. And then so the conjugate acid, add. What I do think is so neat, is so cool, is that, you know, you sit here and you do all this stuff on paper, and then guys, you go into the lab and it matches it. Like, that's really what I wanted us to do in the lab today, but that's okay. Like, I wanted you guys to figure out these amounts, and then you would make it yourselves, and then you would go test it, and guys, you would get this pH that you calculated. Like, I wanted y'all to have that experience. Maybe Monday, we'll see. Like, I wanted y'all to experience that, because you're like, oh, yeah, I did it, man. It's so fun. This is not so much fun. I understand that. What do we need here? Why do you think we need, this is what Caitlin said earlier. Why do we think we need pKa here? Because we added acid? We don't need that, because this buffer system is still a base buffer system. Okay, so we're still solving. I understand. We got to be sure that we don't fall into that trap, right? Okay, guys, that's why y'all are going to get faster at this weekend. With your active chem and with that lab worksheet, y'all are going to get way faster with this. I know it already. I know it. I know it. I believe you will be faster. I do not. I have just the right amount. Sure.
It's not your
It's not. I earned my A's. Actually, you guys. Guess what I made in this class when I took it? I took it in the summer. My teacher was the worst teacher ever. His class was so hard. He truly did write tests so that the highest grade would be in the 50s. Like, they were that hard. Because then he wanted to be able at the end of the semester to control what your grade was. And if your grade was technically failing anything he gave you, well, you just had to kind of take what it was. He was also that professor who, if you were a girl and you went to his office for office hours, your grade would go up.
How you doing?
See, I wouldn't play. I was like, 19, 20, and I was like, I'm not going to do that. And Carrie Poe nowadays would be like, hey, how are you? Doing? What can I do for you today? Because I still wouldn't. I have too much respect for that. But I did make a C in this class. This is the only chemistry class I ever made a C in. Do what? Oh yeah, even after making a C in this terrible class, I still wanted to do chemistry. I still loved it. I know that's why I got the damn C. I know it. I'm still pissed about this day. It's fine. What did y'all get for your POH? 4 point what? I'm about to fan. I can't hear you. 4.44. Triple 4. So then the pH is, hey, and our pH went down, right? What is it? 9 point what? 9.56. Our pH went down when we added acid, like we should have expected. Good. Okay. Let me look at this active chem and see what number you guys can get through absolutely this weekend. And then if you felt inclined to learn about titration curves on your own, you could go ahead. But I'd be I want you guys absolutely like I want you because here's the thing, the buffer stuff, we're gonna use it again in the next section. So like y'all spend this weekend getting so good at buffers. No, like the titrations. We're gonna use it in this. Y'all get so good at this. Like and the salt hydrolysis thing, like predicting is it acidic or basic, and then calculating, but where you got to calculate the Ka when I gave you the Ka, like the salt thing, y'all get good at that. Okay. You'll do it this weekend. You got 4 days. Plus you got Jesus on your side because he is risen. Okay. So Sunday, he is risen.
I'm gonna go to Stations of the Cross.
Mm-hmm. I can't go tomorrow to our thing because we have softball game. Yeah. I don't know. Let's see. We got practice tonight, so we'll see how hyped I am after our practice tonight.
Is this supposed to wait for?
Fuck it. I mean, I don't know. I don't know.
Monday.
All next week was bad.
Y'all, for Lent, I was like, I'm gonna give up cussing.
Not me.
It didn't happen. I wasn't good at it. I tried real hard. Oh man. Okay, guys. So this chapter 14, set 2, right? Y'all can get through. I want to say it's 20 something. Hang on. $22. Excuse me. And then like the last 10 questions, 24 through 34, are titrations. It's you can certainly some of them are still they're just acid-base reaction questions. Like when you react an acid and a base, what are the two things you make? Salt and water, right? Okay, so there's some of that. I mean, you can certainly look at some of that. Some of it is just like reaction stoichiometry. So, yeah, so I mean, you can certainly take a look at them, but there will be some that you're like, it's because it's a titration question, and we got to talk about it through question 22. Through question 22 for sure. Okay. Still can't do the last page. The last page of that lab worksheet is titrations. What is that? I think it's 1 through 14. On the lab worksheet. Yep, you should be able to do 1 through 14. I guess Wednesday, if we're going to have the test Wednesday, which we will now, because we didn't get that's the new plan. Yes, test will be Wednesday, new plan. So I hope Melton moves y'all's to Thursday. Sorry.
Well, that's what he said.
Okay.
He said it would be official on Monday.